And welcome to week 4 of our Maintenance Statistics 1 students. We're still just working our way through representation of data, I think, in class. I'm recording these ahead of time. So we will just be continuing to refresh our minds on some of those concepts here in these videos. So the first question, again, we've got a past examination question. We've got a table with some data of 112 people and the time it takes them to travel to work in sort of a grouped frequency table. And the first thing that we've got to do is state the time interval in the table which contains the median and which time interval contains the upper quartile. Now, key piece of information is that we've got 112 people. So the median piece of data, median, if you divide 112 by 2, it's an even number, so you're going to be looking at the between the 56th and the 57th term values, so you want to add those two together and divide by 2. Sorry, yes, 56th and the 57th, yes, that's exactly right. So all you need to do now is go, alright, 19, by the end of this, we've got 19, 29, 31, 31, so it's going to be in this one here, in this here, so median, in 15, is less than t is less than or equal to 20, okay. Now, because your data splits neatly into two parts, so you've got the lower 50%, you've got 56 items there, and the upper 50%, you've got 56 items there, and you're wanting the upper quartile. So we take this amount here, we divide it by 2, and you see you've got 28, 28. So we want to find the upper quartile. So we are going to divide that 56 in 2. So that gives us 2 lots of 28. So we're looking for the 28th and 29th, and it would be in between those. So all we need to do really is go 56 plus 28 and see where that takes us. So 56 plus 28 gives us 84. So we need to find out where is the 84th and 85th term. So if we count along here, we've got 19 plus 12 plus 28. That takes us to 59. Plus 22. That takes us to 81. So by the end of this, we're at 81. So you can quite clearly see that the 84th and 85th values are going to be in this one here. So upper quartile will be in the range 25 is less than t, is less than or equal to 40. Okay, so that's essentially how that one works. Now we're going to draw a histogram to represent the data. So in the histogram, I'm going to do frequency densities. So the frequency density here is 1.9 because 19 divided by 10 is 1.9. Then I'm going to do 12 divided by 5, which is 2.4. And then I'm going to do, the next one is 28, and I'm dividing it by 5. And the reason I'm dividing it by 5 is because this class width from here to here is 5. So that one is 5.6. And the next one is 22 divided by 5. So that should be, 4.4, sorry. And the next one is 18 divided by, now it's at 15, which gives me a 1.2. So these are my FDs, frequency densities. The last one is 13 divided 20, which gives us 0.65. Okay, so we've got our frequency densities. So let's move this into position a bit more. We'll go frequency density. I'll probably write that properly in full words, but I'm not going to do that today. So 1.0, 2.0. Oh no, that's not going to work. Oh, that's really annoying. Okay, never mind. 1.0, 2.0, 3.0, 4.0, 5.0, 6.0. Okay, so that'll do. Now, and if we go along, what can we do here? 10, 20, 30, 40, 50, perfect, 60. All right. And we probably should have a label for this, shouldn't we? So this is time to travel to work in minutes. And okay, put some base, we'll try these shapes in here. So the first one we want 1.9. So 1.9, and that's from 0 to 10. So it's sort of thing here. Oh, okay, we can't really get that to the exact size I want. Okay, that'll kind of do, I guess. The next one, maybe I'll just do it by hand. It'll look worse, but at least be better. Okay, so it should be roughly 1.9 there. Okay, the next one is 2.4, and it goes from 10 to 15, so 15's here, so 2.4 would be approximately there. Oops. Okay, and the next one is 5.6, that's 15 to 20, so 5.6 would be here. And whoops. And straight down. Drawing on this tablet's not so easy. Okay, and the next one is 4.4, and that's between 20 and 25. So 4.4 is approximately there. And again, just straight down here. And then from 25 to 40, so this is a fatty, that's 1.2. So it's all the way along to there. And then we've got 40 to 60 is 0.65. So 0.65 is probably just 2, 4, 6, sort of a little bit over there. Oh, I've gone a bit high there, but you get the general idea. It's a bit hard to do these graphs like that. Okay, so probably that would be all I would need to do for this. Yep, okay. Now, calculate an estimate of the mean travel time to work. Okay, so for an estimate of the mean, I'm going to be needing to look at the mid-interval values. So I will just write the mid-interval values up here. 5, 12.5, 17.5, 22.5. What one's that? It's 15, so it's like 32.5. And the last one is 50. Okay, and remember, the estimate of the mean is the sum of fx over sum of f. Now, in this case, we're using the mid-interval value, so it'll be like 5 times 19, right? This times this, plus 12.5 times 12, plus 17.5. Look, I'm just going to give myself some more room here. I'm going to get rid of this graph so that I can write big enough for you to see without it being horrific. Okay. 17.5, and that's times 28, plus 22.5, and that's got a frequency of 22, plus 32.5, and it's got 18, plus 50 times 13. Now we're going to divide that by the total sum of the frequency. Now altogether it says we've got 112 people, so I divide this by 112, and let's see what we get there. A big long fraction. 5 times 19 plus 12.5, I don't know why that's come back. Go away. 12.5 times 12, 17.5 times 28, plus 22.5 times 22, plus 32.5 times 18, plus 50 times 13. We divide that by 112, and we're getting 22 point, essentially if we round it to three significant figures, 22.0 minutes. Okay. All right. I don't know what happened there. Okay. Now this next one is one of those nasty coding type questions. So let's have a quick look at this. So we've got amount of money, X dollars, that 24 people had in their pockets are summarized by this fact. So this, we know the sum of X minus 36 is equal to minus 60. And we know sum of X minus 36 squared is equal to 227.76. And we've got to find sum of X squared. Okay, well, what we're going to do here is we know that this bit here means I've taken every single of one of those 24 people, I've taken their money and then subtracted 36 from the amount of money that each of them has to get minus $60. So if I take that minus $60 and then I add 24 lots of 36, because I took that $36 off all 24 people, I should have the original amount of money that those people had altogether, or the sum of that. So that's what I'm going to do. 24 times 36. Okay, so altogether that's 804. So therefore, the sum of X is equal to 804. Okay. Now, the next bit that we're going to do is we're going to try and find this here, the sum of X squared. And we're going to use the variance formula. Now, the trick to this is the variance will not change. So the variance for the data when it's like this, with the minus 36, will be the same as the variance for the data when it's sum of X squared. And the reason for that is variance is a measure of spread. And if you just move everything by the same amount, right? Let's say we've got these three dots here, and we subtract 36 from them. So they start off here, we move them 36 this way. Has that spread changed? No, the spread stays the same. So we can use that fact to help us discover our unknowns. So let's look at the variance for the data that we have everything of. So variance, we know the formula is equal to, and we're not doing the square root, that's when we take the square root of it, we're getting our standard deviation. So variance is the sum of X minus 36 squared over the number of pieces of data. So this is 24, minus the mean. So that would be, now to find the mean in this case, that would be the X minus 36 over 24, because there's 24 people, right? The mean squared. So this bit here is what we have normally in the formula is that mean squared. Okay, now, if we just chuck in some data for this to see what we come up with. So, another way of writing that is 227, because we've told that that's what this is here, right? 227. I'm going to pop that over 24. Then we're going to subtract the mean, which is negative 60 over negative 60 over 24, and we square that. And that will give us the standard the variance. So I'm just going to chuck this on the calculator now. Minus, and then I'll open bracket, minus 60 over 24. Square that. Okay, so this is giving me 3.24 as the standard deviation. Sorry, the variance. Now, if that's the variance with the data that we know, we can now use the formula for variance with the data that we don't know, the original data before it was coded. So sum of x squared over 24, because there's 24 pieces of data still, minus the mean, now, which is going to be this, divided by 24, and we square the mean, right? And that should be equal to 3.24, because the spread remains the same. Now, we don't know what the sum of x squared is, but we do know what sum of x is, because we worked that out in the previous part of the question. So we should get this. And now what I'll do is I'll move that 804 over 24 squared across the other side. So I get 3.24 plus, just going to open bracket, 804 over 24. We're going to square that whole thing. So I would get the sum of x squared over 24 equals, what have I got here? 1125.49. Okay, at this point you can see that there's only just one more step to go, and we just need to times both sides by 24. So I'm getting sum of x squared equals, what's this, times 24? A big number, 27,011. But to three significant figures, we can just say 27,000 to 3 SF. Okay, I hope that makes sense. These coding ones are a little tricky at first, but you'll get the hang of them. Okay, the last one that I'm going to look at with you today is a machine. It's supposed to produce bearings with a mean diameter of 2.0. A sample of 8 ball bearings is taken from the production line and the diameter is measured. Okay, I think these are meant to be separated here. There's 3 different ones here. Okay, so we've got to calculate the mean and the standard deviation. So the mean, I'm just going to chuck those values into my calculator and divide by 1, 2, 3, 4, 5, 6, 7, 8. There's 8. There's 8 ball bearings here. So 2 plus 2.1 plus 2 plus 1.8 plus 2.4 plus 2.3 plus 1.9 plus 2.1. If I divide that by, what did I say? Was it 8? I get 2.075 as my mean. And the standard deviation is equal to, so we're going to go, remember that what the formula is, so the sum of the x values squared divided by the number of values. So we're going to go 2.0 squared plus 2.1 squared plus 2.0 squared plus 1.8 squared plus 2.4 squared plus 2.3 squared plus 1.9 squared plus 2.1 squared. We're going to divide that whole thing by 8. Then we're going to subtract the mean, which we found in the previous question, squared. Now what does this give us? Oh, and of course I've got variance here, so I need to square root this. And that gives me, what does that give me? 0.185. Whoops, 185. There we go, 3 significant figures. Okay, so this last question is, do you think the machine is correctly set? Well, we know that we're looking for a mean of 2.00 mils. And the mean that we got was actually 2.075. So it's slightly higher. Now the standard deviation is 0.185. And you can see the difference from here to here is less than half of one standard deviation. So this is what one standard deviation is. So you can see this is less than half of a standard deviation. Now, you know, when you're looking at a bell curve like this, you've got within one standard deviation, either side, I think it's within one, you've got, I think, is it 68.5%, 68%? Yeah, 68%. So the fact that this is lying within half a standard deviation suggests that it's probably correctly set.